Okay, my job for today is to teach you how to do this. Well, function graphing. Uh, we're going to start talking about odd and even functions. And to do that, we need to be pretty darn good at all the graphing stuff you used to be able to do in higher algebra. So I'm going to remind you of some of those things. To start with, find this page in our notes and just graph that. Just simply graph that. I know it's a little strange looking. How would you write it if you wanted to put it into mx plus b form? You'd say y equals what? Negative x plus 2. Excellent. And that'll remind you where to start and what the slope is and that kind of stuff. Okay, would you turn your iPad my way so I can see what your sketch looks like, and I'll tell you if you're generally doing it right? Yup, 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 yup. You started right, and there you go. Good, 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 good. Yup, yup. Okay, good. So people started here, and then with a few little oopses here and there, but got around to getting it like that. Okay, would you agree to start with that that doesn't have any of the kinds of symmetry that we studied? If it had origin symmetry, you'd have to have a point right through here, right through the origin. That would be on the other side, and it'd have to be like another one over here. And then it wouldn't be a function because it wouldn't pass the vertical line test, and so it's really difficult for this to have any kind of symmetry. If I'd have drawn it like this, would it have had symmetry? Yeah, the kind where it reflects across the y-axis. Okay, just a quick reminder on symmetry types. All right, so your job on this is to, well, sketch the graph. Okay, cool, done with that. What if you didn't know what it looked like? Like, what if you would just have a brain fart and you can't figure out what x squared looks like? And then you just have to take x squared and move it up one, right? But let's say you forget. XY chart solves any kind of graphing. All right, state the domain. If I'm looking at this red one, domain is like this way. So negative infinity, positive infinity. And then identify any intercepts. All right, fill in this sentence for me. The y-intercept is where x equals 0. Good. So I put in x equals 0, and looks like 2 minus 0, so y is 2. And there you go. And that's this spot right here. And so if I was naming that, I'd go x int. If y is 0, it's something comma 0. Oh, wait, that's the other one. Y int. The y-intercept is where x is 0. So 0 comma. Okay, the y-intercept is 0 comma 2. X-intercept, can anybody help me out with the x-intercept? 2 comma 0. This one's so easy. I'm just reminding you how to, like, you say those sayings, because when it gets weird, like this one, and you're trying to figure out the y-intercept's easy. You just stick in x equals 0, and that's 1. But how about the x-intercept? Fill in the sentence. The x-intercept is where y equals 0. You'd put a 0 here, and you would solve. You subtract 1 from both sides, and you'll be like, wait a minute, I'm supposed to take the square root of negative 1? What does that mean about the x-intercepts? There aren't any. And think about it. This is what it looks like. Does it look like there's any x-intercepts? No. Okay. All right. So that's the reminder of how to do all of those little things with functions. But what's the new thing? The new thing is this. Looking at this, do you remember how this has that kind of symmetry where it goes across the y-axis called y-axis symmetry? There's a new name for that. That is called a function that is an even function. This is not an even function because it does not have that kind of symmetry. Okay, so this has y-axis symmetry, and that makes an even function. An even function has y-axis symmetry. Now, do you remember the type of symmetry that was like this? It wasn't y-axis symmetry. It wasn't x-axis symmetry. It was called Origin symmetry. And origin symmetry is the other kind. Take a logical guess. What do you think we're going to call this? It's got origin symmetry, so this is called a blank function. If the other one was called an even function, an odd function. Okay, so this is odd, and it's got what kind of symmetry again? Origin. So some of your questions could be as simple as that. They give you a picture, and they ask you, what kind of function, or sorry, what kind of symmetry does this have? Well, it's got y-axis symmetry, so it must be what kind of a function? That's an even function. Now, one thing that confuses people sometimes is if I move this over a notch like this, does it still have y-axis symmetry? No, it does not. Therefore, it does not an even function anymore. Just by moving it, it's not an even function. All right, I'm going to shut this door. All right, so what if it's a shape you don't know? That's what we really have to use now, is like, what if you don't know what it looks like that? I don't think anybody knows what it looks like. Well, you could always find out what it looks like by finding a bunch of dots and connecting the dots. This is a really important skill, using the XY chart. Would you please find me 3 points that would be on this graph? We're not going to try to graph the whole thing. I'm just reminding you of a super important skill. Graphing. What if you don't have the parent function memorized? Find me 3 points that are on this function. In a moment, I'm going to ask you to compare with the kid sitting next to you. So have yours ready and legible, and I'm going to pause for a second while you find 3 points that are on this function. So you stick in 0. I hope you're smart enough to pick that one because it works out really nice and you get 0. Raise your hand if yours went through 0, 0. Awesome. Now there's a few other points. Oh, F. Give me 1. You did so well on your last test. I know I can pick on you, and you probably get it right. Well, just messing with you. Yes, it works. 1, 3. Raise your hand if you actually put in 1 and got 3. Okay, awesome. And OC in the back. And I'm not talking about Orange County. All right, good. Now stay with me. I saw your iPad change a lot right when I called on you. All right, so if I stuck in a 2, you're saying I would get 12. And you were right, 212. Okay, awesome. Now if I graph those, in case you're having trouble with that, 2 to the 3rd was 8. And then 8 plus 4 makes 12. Okay, so over 2 up 12, over 1 up 3, over 0, 0. Now, I happen to know what this thing kind of looks like because I know it's an x to the 3rd. Does this sort of seem like it's following that sort of a pattern? Do you think there's a chance it might actually have that perfect origin symmetry? It might. If it didn't have this 2x thing, I would know it does because x to the 3rd is a classic example of origin symmetry. So the question becomes, how do you tell if something like this has even, or sorry, if it's an even function or an odd function? All right, so here's how you tell. There's a rule. I'm going to back up to when I first asked you this. So, here's your function. I said to graph it to get the idea of what it kind of looks like. There's a rule. If this isn't called y, what's another name for it that we could use? F of x. Then, let me show you something. I think I can develop how this works pretty quick, and then we'll see if you catch on. Do you get if I stick in 1, I get 1? And if I stick in -1, I also get 1? On an even function like this, whether I take f of x or f of negative of the x, you get the same thing. See what I mean? Okay, let's say I put in 2. Then it goes up to 4, right? If it's a normal parabola. Then if I put in -2, I still get positive 4. If I put in a negative of the x, I still get the same as when I put in regular x. It came out to 4 either way. So what I'm trying to say is that f of negative x is equal to f of x. to write this down. This is called the odd rule. And yes, you have to remember this, and yes, you have to write it down on your test. Last time, I don't think I was tough enough about this, because I said, just prove f of g of x equals g of f of x, and that they're equal to x. And the problem is half the class, not half, but a lot of kids, only did like f of g of x, and it came out to x, and they were like, see, I proved it. You have to do it both ways. G of f of x had to equal f of g of x. That was for inverses. For this, the odd rule is that f of negative x has to equal f of x. And if it does, you have an odd function. Do you get that there will be a even rule too? And that goes like this. If I write this down also, the even rule is that if you take f of negative x, you will get negative of the f of x. What? I tried to show you on the picture how these work, but I'm at the point I don't want to spend a long time trying to explain why these are the rules, but these are the rules, and let's make sure you get the difference. Do you get how they both start with f of x, f of negative x equals? They both start with that. And they just end with, one of them says it comes out to f of x. The other one says it comes out to the opposite of f of x. In fact, I'd even like you to put a -1 times right there. Instead of just negative f of x, -1 times f of x. So, and I just wrote them backwards. Doggone it. Change the word odd to the word even. And I know I said that, and I wish you would have, like, just, I know some of you were looking at it funny, but you weren't saying anything. I was trying to figure out, what am I doing wrong? This is the odd rule. And you know how I caught myself? The reason I caught myself is I usually tell kids this dumb little way to remember it right now, and that's if there's negatives on both sides, that's odd. Get it? It's the odd rule. If it has negatives on both sides. This one doesn't. This one only has a negative in there. Okay, so I'm going to try to show you why this works out the way it does. If I put in a spot here, 2, 8, do you get that it would give me on the other side down here the spot -2, -8? And what's that saying? That's saying if I do negative of the x, see, negative of the x, that I get the opposite of this, see? 8 turns into -8. All right, if that doesn't work for you, you get a minimum, got to be able to go back to this. I'm about to try to prove that this, well, I had a third there before. I'm going to go back to the one I had, just in case you think it's the one I had originally. There, I think that's the one I had originally, right? Yeah. I'm going to prove to you that it's either odd or it's even. Or what if it isn't odd or even? What do you call it then? Neither. It's either odd or even or neither. You have to prove each step. You got to prove it's not even. And then you got to prove it's not odd. And then you've proved it's neither odd nor even. Okay, my gut feeling is there's no way this is going to be an even function. But I still have to prove it. Just because I know kind of what it looks like, it's kind of got a wave going on, I'm not almost positive it's not even. You can't just use that. That's not good enough. What is the even rule? Have you got a decent short-term memory? F of, what was it again? -x, they both start that way, equals f of x. So this, y, would you agree that y is the same thing as f of x? We substitute those back and forth a lot, okay? So now, I've got f of x. What do I need to figure out? F of -x. And I got to see if they're the same, right? I got to tell if f of x is the same exact thing as f of -x. If I can tell that they're the same exact thing, then this must be even. All right, watch. Now I'm going to say, what's f of negative x? It would be empty spot to the third plus 2 empty spot. Everybody do that now. Don't just watch me. All I did is write a parentheses underneath. Where the x's were. Okay, now take a wild guess what I'm going to stick in that parentheses. A negative x. All right. So if I put in that negative x, and now I have to simplify it because I can't just leave it that way. Of course it looks totally different. But maybe when I simplify it, it'll be the same. F of negative x turns out to be negative x to the third. It wouldn't matter if you left the parentheses. Ideally, you take the parentheses off. Minus 2x. That's where the real, whoa, I can definitely tell this thing is different. Do you get f of negative x is not the same as f of x? Does that make sense to you? We have just proven, therefore, and in case you didn't ever learn this before, this is a really handy set of 3 dots. Anybody know what it means? It's shorthand, and it's used in science classes too. Have you guys ever seen the triangle? And that one means change. Does that ring a bell? All right, in case you've been in a science class before, the triangle means change. This means therefore. 3 dots like this saves you the word therefore a lot faster to write. Okay, therefore, didn't I just prove that this was not even? Not even. Now, on the same proof, you are going to have to write both rules, even rule and the odd rule. What is the odd rule? F of negative x is equal to negative 1 times f of x. Awesome. It could just have a negative instead of a negative 1. It's the same thing. Well, if it's not even, does that mean it's for sure odd? No. I have to prove now whether it's odd or not. Do you get, I already have f of negative x right there. I do not need to go refigure that out. I already have f of negative x. So here's the tricky step. I have to factor out a negative. See if you can hang with this. This is where being good at your algebra, what I try to beef up on that top 20. Factoring is one of the big things that's on there. Is can you factor out a negative 1? It's not one of the skills that's on the top 20. If I was going to make a next 20, you know what I mean? The one after the top 20, that's just like the top 20. Factoring out a negative 1 will be on it. Because this, so many people. Can anybody tell me what I should put on the inside if I factor out a negative 1? What do you think? What did you do? You write. What did you do? What did you think about when you did that? Nice. That's what factoring is. Factoring means I'm going to divide these by the thing I factored out. All right, that's the halfway mark. Not over yet. Do you get that that leaves me with this? And here's another way to say it. Do you get if I did it right? If I multiply this in, I got to get the original back. Do you see that I do? All right. So now, let's see if you can follow this. All I did is factor out a negative 1. I know you can learn to do that. But let's see if you can follow this logic. Do you agree I did not change this value? I just wrote it differently. I wrote it as a factoring problem where I factored out the negative 1. Do you agree that this is still f of negative x? They're still the same. This is equal to this, right? F of negative x is still there. It's just factored different. So now, let's see if you can hang with this. F of negative x is now equal to negative 1 times f of x. Process this. What am I really saying? That is f of x, isn't it? How do I know what it's f of? It's up here. It says so right there. It says that f of x is x to the third plus 2x. I know up until this step, you were fine, because all I was doing is sticking in a negative x. We'd done that a million times. Stick a negative x into a function. The reason we were doing that is for this day, because you got to do this a lot. So in your next test, you're going to be sticking negative x into everything all the time, because it tests these symmetries, and then it tells you if they're odd or even functions. What you're not used to is this format and having to factor out a -1. For some people, that'll be their kryptonite. They just don't get how to factor out a -1. But for more people, they're going to be like, okay, so what? I factored out a -1. Now what? You're looking to see, this hasn't changed. -1 is now -1. Is this really f of x? Do you get that this is our rule statement? That's our odd rule. Is this really f of x? Is it? Yes. Therefore, odd. That is an odd function. It's for sure odd. If you graphed it, its inflection point would be right at the origin. As in, it's one of these dudes. And so it's got odd symmetry, and therefore, I shouldn't say that. It's got origin symmetry, and therefore it's odd. All right, here's another one. This is the only really hard part, is what we're doing right now. But it's also R3 level stuff. The other stuff I'm going to teach you at the very end of the hour, it's only R2 level stuff. It's not that hard. Okay? All right, so here's another one. What if we have f of x is 2x squared plus x? Now, first off, I'm confident this is not odd, because I know it's kind of a parabola shape. You know why? Do you remember back to higher algebra when you had squared things? They always have both ends up or both ends down. Do you remember that? What if it was what if the biggest power is negative? Sorry, not negative. What if the biggest power is odd? Do you remember how they were opposite ways? You know what I mean? Okay, so I know that this is going to have both ends up because there's no negative in front of it. Do you remember that? This has to have both ends up. I don't know exactly what it looks like, but both ends are up. Do you get that means it can't have odd symmetry? This thing's not going to be odd. The question is whether it's even or not. Would you please try that test I just showed you and see if it's truly even or not? First, I'd write out what the rule is. What is the even rule? You can look it up in your notes if you have to. Yes? The question will be, prove if the following function is odd or even or neither. Now, if you've proven it's even already, you don't have to prove it's not odd, because if it's even, it can't be odd. Okay? But if you've proven it's not even, does that prove that it's not odd? No, you have to actually go through the proof of both. But once you've found that it's one of them, then you're done. You don't have to keep going. If you know for sure the thing's odd, then you're done. But usually you're going to test for even first. All right, even. Oh, I just did it wrong. F of negative x equals f of x. Good. All right. Step 1, RH. Tell me what to do. Yep. And what did you get? Nope, you can clean it up now. But it's not. And let's talk about that. The negative squared means it'll be positive. Okay. Then, plus negative, you can simplify that to just negative x. Now, we now know f of x. They gave it to us. We now know f of negative x. Are they the same as each other? No, and therefore, I can say dot, dot, dot. Therefore, not even. All right. I'm pretty sure it's not odd, but that doesn't count as a proof. Okay, so here's how you prove it. What do we factor out now? -1. Notice this is still f of negative x. I'm just taking out a -1, which you can do to anything. Newsflash, you can factor out a -1 from anything, always, forever, for the rest of your life. It's okay. Doesn't change the value of it. If I had the answers 2, I can factor out a -1. -1 times -2. There, it's factored, and it has a -1 in front, and it's still equal to 2. See what I'm saying? All right. So we're just taking out a -1. And I get -2x squared plus x. Now here's the question. F of -x is clearly f of -x, -1. And then the question is, that's supposed to be f of x if it's going to follow that rule. So is that f of x? No, it's not exactly the same. It has to be exactly the same as the original f of x, and it's not. And I can say not same. Therefore, not odd. And if it's not even and it's not odd, therefore, neither. That's the hardest kind, because you have to go through the whole proof for even and the whole proof for odd, and then you come up with the final answer. Yep. Well, this is a new unit, so there'll be other things, but it's definitely it's an R3 level question. And to do a neither is the hardest because it makes you do even and odd. It might be easier, like let's say it was on the test as an R2. It might be just show these aren't even. Know what I mean? All right, so that's what I'm going to do right now. Show me. No, make something a little harder. Show me that you can prove that that's not even. Just prove it's not even. Prove that it's not even. How many of you remember to actually write the even rule? Only a few people get full credit then. You need that on the test. You need to show what you're trying to prove. What you're trying to prove is that this equals that. I know most of you stuck in -x, which is great, but you need to have the whole proof, which is, here's what I'm trying to prove. Now let's see if it worked. And I stick in -x, and I get there. That and that are not equal. That is not equal to that. Therefore, not even. Let's say they then said, the problem was a more general. Prove whether it's even or odd. You would have started with that. Just do one more step, and you'll be able to tell if this thing is odd. Just add on one little step. Now, in a moment, I'm going to have you check somebody else's and vice versa. Show your work well enough so they can see it. I want to sketch now who doesn't know how to factor out a -1. Not because I want to like harm them. I want to help them learn how this part works. In a moment, I'm going to ask you to show the person across the aisle from you, and it's going to take them a second. Don't just assume that you can glance at it and know they're right. I want you to look at the end of their proof where they conclude either it's odd or it's not odd. Okay? Rows 1 and 2. Hold your iPad out so they can see it, or turn it on your desk so they can see it. I want you to look at theirs, look at your own, see if you think they have proven that it's either odd or that it's not odd. And I know some people just don't know how to do this yet. It's okay. Yeah. There's a person like kind of diagonally. She'll help you. Okay, here's exactly what you should have shown. Negative 1 comes out. Negative 2x squared plus 3x. That's what should be on the inside. Was that f of x? Was that exactly this part right here? Was that f of x? No, it was not. No. And therefore, not odd. That's the same exact proof you're going to be doing in calculus, except they're going to hope that you remember it. My gut says that they're going to know that you're probably not, but you're going to hopefully at least remember this well enough to do well on your next test. And those of you with the steel trap memory can be like, oh yeah, I remember this one. And those of you who aren't so steel trappish, when they review it for you, hopefully it'll come back fairly quickly. But this does get tested in calculus too. Yes? Yes, on every problem, the typical question doesn't just say, prove it if it's even. They'll say, which is it? And remember, once you've proven it is something, then you can stop. And if you've proven it's even, like we always start with even. If it's even, you can stop because it can't be odd. But if it comes up no on the even, then you have to test that next if it's odd. All right, so that's the hard stuff. Now, I want to take a few minutes to talk about the easy stuff on tonight's homework. Honestly, it's easy. It may look hard, but it's this, and it's long, but they're all super simple questions. Would you please get to this page? There is stuff like this on your test. It is so easy that we usually make it like a multi-part question, though. You know what I mean? Like, you can't just answer one of these questions. It's too easy. But they might have a question on the test like this where it's got like 5 parts, and you got to get them all right to get credit for your R2. Okay, so let's make sure you understand all these kinds. The range of this function. Notice if it just says f, they don't have to say f of x. That's assumed. Okay, so what's the range of this function? Well, I hope you know what range means. So that's the low to the high. Don't overthink that. Next up, solve f of x equals 4. Hint, what's the same as f of x? Y. So that's like them saying y is 4. And what they want is solve. What are you solving it for y? You would already have it. If you was asking to solve for y, if they were asking you to solve for y, you'd already know the answer. So what are they asking you to solve for? X. They want to know x. Okay. So you got to figure out what x is if y is 4. Well, here's where y is 4. It's a line, and it happens to hit there. I think that's important? Probably is. All right, the Y-intercepts. I'm going over this very quick because you did learn this last year. I know you did. We're talking about these same things in higher algebra this year, right now. So I know they've done it. You've done it in the past. The Y-intercept, fill in a sentence. The Y-intercept is where, what? X equals 0. And x equals 0 is this line right here. Oh, it hit right there. I wonder if that's important. Of course it is. All right. The function is greater than 0. Now, that's been a while. And I don't know if you ever did it in this context. Would you agree that this is the function? Where is it, the function, bigger than 0? Well, the question really is it where x is bigger than 0? No, where f of x, which is really like saying what? Y. Do you get how they're saying this the function? Where is y bigger than 0? And if you're like, well, if the y is bigger than 0 in here, how are you going to say that? It's called an interval. It's an interval between what and what? Between -4 and -1. And doesn't it touch on the ends? I actually would have had to accept it both ways because when it's an interval between two numbers, it's hard to argue that at that spot, no, actually, wait a minute, I'm wrong. You're right. It says equal to 0 is a possibility. Greater than or equal to 0. At this spot, it is equal to 0, so that spot works, and I should use brackets only. Yep. Is that the only place? No. There's another place. This one, you got to be more careful with your brackets and parentheses. All right. This says, does it appear to be? Does that say to prove that it's even or odd? No. It says appears to be? Does it appear to be even? Does it appear to be odd? There you go. It's just appearances. You do have to recognize the pictures. This one's an easy picture because it doesn't work. There's no way it has y-axis symmetry or origin symmetry. Neither one. All right. Intervals where f of x is decreasing. Hint, decreasing means going down. Like, that's one of them. So how do we say that? From here to here, which is x-wise, from -3 to, not -1, that's a y thing, to 0. And this one, you could definitely argue, is it still decreasing at the very end point? Hasn't it stopped decreasing right there? That's one where I would accept brackets or parentheses, either one. 12-minute warning. Okay, so it's between -3 and 0, and I would accept parentheses or brackets. I personally, I actually like parentheses better on this one, but I already drew the brackets. So, okay, local minimum. That's just the low spot. Is there a low spot on this graph? Yes, there is. It's like a place that would collect water if it rained. That's a local minimum. Now, I would also have accepted that this is a low spot and this is a low spot. But would rain have actually collected there? No, it's kind of dumb, but it's supposed to go up on either side of the low spot. Otherwise, it really isn't a local minimum. So we're getting into fine points here, but all three of those could be argued as local minimums, but only this one is really a local minimum. Now, again, very picky fine point here, but which of these is the lowest of them all and therefore called the absolute minimum? That one. When you're talking absolutes, it doesn't have to have like something on both sides of it. The lowest spot is the lowest spot. That's the absolute minimum. And I think you would know that that would be the, what do you think, absolute maximum. Okay. There. We've covered everything that you would need to know on this page. If there's any of this you don't know, you should definitely go look at the key to figure it out because you need to know how all of these things work. Okay, now one thing you may have noted is that there's only 2 problems on this whole assignment where you have to show and test for symmetry. And it's these 2 super simple ones. I want you to do one more. These 2 are ones I'm assigning. Yes, you should test those for symmetry. But I'm totally okay with us skipping this whole page, the pink page, and the whole green page. That's a lot I'm having you skip because I'm adding in one more thing. I want you to prove that this is a neither. It's not even, it's not odd. So go through the even proof first, then factor out a -1, and then see if you can prove that that is neither. Maybe you guys should actually say neither. Some people do. When Santa comes and his sleigh lands up on top of your house, what's he landing on? The roof? Roof? You go with the ooh sound for roof? But if you're pulling up a plant, you got to make sure to get the root. Is it root or root? Yeah. Is there any actual bagel peoples in here? My kids were bagel kids. Yep. Okay. So neither is the way I say it. If you want to say neither on the test, it'll look the same. They're spelled the same way. All right. So you have one add-on problem. I've never done that before. Do that problem. All right. So, and also I haven't graded homework in a while, but it won't be tomorrow. But that doesn't mean I can't grade it when I come back. So I have a strong likelihood I'm not going to be here. I haven't actually called it in yet. And in fact, I actually feel a little bit better right this second. But anyway, if I'm gone tomorrow, I obviously can't collect the homework, but still do it. Because when I come back, I could say, okay, you remember that one? Because this is a pretty doable assignment. I'm less likely to grade one where I have a sub playing a video about the lesson. Because, yeah, I wasn't there to ask questions. You couldn't ask me questions and whatever. So do your homework. Get it done. All right. That's all I got for you for now.